Hello, Anandal. I am Manisankar studying ECE in Jansen's Institute of Technology. Today I am going to explain about the sound detector circuit using Op-Amp741, which is for the purpose of case study for the subject linear integrated circuits. Let us move into the topic. Let us see about the introduction to sound detector circuit using Op-Amp741. Sometimes due to lack of concentration and our ignorance, we are unable to hear anything around us, and that could lead to unfortunate misfortunes which could have been avoided with appropriate precautions. This circuit called sound detector is what detects vibrations of the sound waves and amplifies it to be heard distinctly by human ears. As per the design of the sound detector circuit using 741 IC, it works efficiently within the 6 meters limit around the vicinity where it is fixed. This setup can be done in any desirable places like car porches and at the corners of the house. As soon as a microphone incorporated in the project detects sound wave vibration, the sound detector circuit using Op-Amp741 produces beep sounds to alert people around that area. This is the diagram. This is the picture of a sound detector using Op-Amp741 in practical mode. Let us see see the descriptions also. Here it is a circuit diagram for this 741 IC sound detector. Here you can see the IC diagram and then the resistors like this. Here in following pages we will see about the description of the circuit. The heart of the circuit is Op-Amp741, which is used in order to sense the vibration of the sound waves condenser microphones. So in this picture you can see this is the IC, this is the heart of this circuit diagram. The sensitivity of the condenser microphone is adjusted by the value of resistor R1 used in the circuit. So the sensitivity is adjusted by this resistor R1. Once the microphone detects the sound vibrations, it picks them up and converts into electrical signals. Then the output of the microphone is fed into pin 2 of IC1 via coupling capacitor C1. So mic is in here. Here the sound will be get detected. After that it will conduct it through capacitor. After that, then the signal undergoes amplification and it is forwarded to IC2, which in this project serves as a comparator device. The non-inverting pin 3 of IC2 receives input from amplified output signal of IC1 through another capacitor C2. So here you can see the IC2 C2 here also. So through this that process will be get held. In the same way, an inverting pin 2 of IC2 fetches input signal from a reference voltage passed via voltage controller VR2. At the final stage, IC2 output is fed as triggering input pulse to Darlington pair transistors T1 and T2. So Darlington transistors are here present, T1 and T2. Through this only the final stage will be get held. And then a piezo buzzer which is connected at the end of the transistor T2, that is at the emitter terminal, is that component responsible to produce beeping sound at the end of operations followed throughout the entire circuit. So the piezo buzzer, where it is here it is located, piezo buzzer at the end of emitter terminal. Then the fascinating fact about this project sound detector circuit using Op-Amp741 is that it can be designed within a small area on a PCB or Vero board as well. To attain maximum possible gain of IC1 and sensitivity of IC2, adjust the respective values of potentiometer VR1 and VR2 as stated in the earlier paragraphs. During practical implementations of the project, if the beeping sound from piezo buzzer goes on and doesn't stop, set the wiper off VR2 towards the ground line. For faultless circuit, follow the instructions given below. Fix the piezo buzzer at a place where people can hear and sensor at the appropriate place where you need continuous monitoring. This is the first point we have to follow for faultless circuit. Then so as to extend the sensitivity of the microphone, connect it using 2-core shielded wire and enclose it in a small case. This is the second point. After that, to avoid noises from AC mains, battery supplies are highly recommended for this particular project. Then we have to consider this PCB design for the sound detector circuit. Here we used the Proteus 8.1 for designing this PCB diagram. The solder side PCB and component side PCB is shown in the following figures 2 and 3, where PCB prototype is shown in figure 4. The following figures are upcoming. We will show this. The figure 2, this one is the figure 2, which is showing the solder side PCB. Here you can see the picture of a solder side PCB. After that we will see this is the figure 3, which is showing the component side PCB diagram. Here you can see this is the model diagram of component side. After that, this is the final stage PCB prototype for sound detector. You can see here. This is where we already see about in circuit description also. And then finally, the part list of sound detector using Op-Amp741 IC is resistors all 1/4 watt and plus or minus 5% carbon. This is the type of resistor which we use here. Here the R1 resistor is of 2.8 kilo ohm and R2 is of 4.7 kilo ohm and R3, R4, R6, which are common, we have used in the value of 10 kilo ohm. And then R5 is equal to 1 kilo ohm. After that we used VR1 is equal to 1 mega ohm and VR2 is equal to 100 kilo ohm. This is the value of resistors we used in this project. After that, if we see about the capacitors, here we used the C1, which is of the value of 0.47 mu of, which is a ceramic disc, and then C2 is equal to 10 mu of by 16 volt. This is an electrolytic capacitor. And then if we see about the semiconductors we used here in this project are IC1, IC2, which are LM741C op-amp, and then T1, T2 is equal to BC548. This is the T1, T2 where it is called as the general purpose NPN silicon transistors. Okay, and then if we see about the other things we used here are MIC1, which is the condenser microphone, and then piezo buzzer, and then a switch for on-off mode, and then a 9-volt battery. Finally, I attached here the reference links, here one YouTube link and also a Chrome link, where I browsed about this project and showing it to you. Thank you.